Okay. సో కొంతమంది వచ్చారు. ఒక 1 minute వెయిట్ చేద్దాం. సో నిన్న మనకు మెర్క్యురేషన్ అండ్ డీమెర్క్యురేషన్ కొంతమందికి అర్థం కాలేదని మెసేజ్ పెట్టారు వాట్సాప్లో. సో దాని గురించి చెప్పుకుందాం. మనం ఎక్కడ ఉన్నాం ఇప్పుడు? ప్రిపరేషన్ ఆఫ్ ఆల్కహాల్స్ ఫ్రమ్ గ్రిగ్నాండ్ రియేజెంట్ అది అయిపోయింది, ఆల్రెడీ వి డన్. So from hydration of alcohols, it is also completed, and by hydroboration, oxidation of alkane. So alcohols preparation low, we are at alcohols preparation. So from Grignard reagent, it is also completed, and from hydration of alkenes, by hydroboration, oxidation of alkenes, and this one oxymercuration and demercuration. Today our topic is oxymercuration and demercuration. So let's start with the oxymercuration and demercuration. Okay, so this is the oxymercuration, how to. So some of the people are commented on WhatsApp. సో అది అర్థం కాలేదు అన్నారు. ఓకే, సో మనం మళ్ళీ అక్కడి నుంచి స్టార్ట్ చేద్దాం. ఓకే, so first of all, what are the reagents we are using in oxymercuration and demercuration process? So it's very simple. We are using two reagents. One is mercury acetate. So this is a mercury acetate, and the solvent. What are the solvent we are using? Tetrahydrofuran. Tetrahydrofuran is the solvent. This is the tetrahydrofuran. And H2O. H2O is the involving in hydrolysis process. So this is the first reagent. The second one, sodium borohydrate. It is a reduction reagent. Sodium borohydrate, reduction reagent. This one, reduction reagent. These both reagents are we are using in oxymercuration and demercuration process. Okay, let's see what is happening in oxymercuration and demercuration process. So this is simple alkene. We take simple alkene. It is a symmetrically molecule. That means the both carbons are attached with the different type of carbons. Unsymmetrically alkene. Okay, sorry, unsymmetrically molecule. In this process, we are getting alcohols. This is a reaction, simple reaction. But what is happening in mechanism? Let's see. So for example, here we take a substituted alkene. So that is a substituted alkyl we are taking. Here the carbon, this carbon I have positive charge, this carbon I have negative charge. Because of the most substituted carbon is always positive ion is more stable, carbocation. The less substituted carbon, carbene ion is stable according to inductive effect. So this is the mercuric acetate ion. So the positive mercury acetate ion, Hg plus OAC ion. This Hg plus OAC ion attacked where the carbene ion. So that means the terminal carbon. So this is the carbon HgOAC attached here. So this is carbocation is always empty at this place. And then what is happening? What is happening? The OH minus in the water molecule, it is a polar substituted highly electronate atom, highly electronegativity molecule. It is the carbocation cation positive charge attacked with this uh, carbocation attacked with this nucleophile. So finally we are getting this product. So after that, this intermediate we are getting. Very simple reaction. So first of all, we are understanding the what are the charges on carbon between these two alkenes. The more substituted carbon have a carbon act as a carbocation, the less substituted carbon act as a carbanion. This is the important one. So this is very important one to prepare this here. So the mercuric ion, it is a positive ion, so attached with the carbanion, this carbanion to form this intermediate. This carbocation is empty, so this carbocation highly electron deficient. At this time, the water molecule, which is a good nucleophile, electron rich atom, so that's why it is attached to this carbocation. So finally, we are getting this intermediate. What is happening in this intermediate? So after that, we are conducting hydro reduction reaction between the carbon and mercury. What is the charge on carbon? It is a positive charge, and mercury negative charge. So we will break this bond between these two. The carbon hydration of water, also addition of water molecule. So the H plus attached here. Finally, we are getting this product. So CH3, and this is the intermediate product. We are getting the product. So okay, very simple reaction. So let's we see the Moyne diagram of preparation of alcohols from different type of um, starting reagents. First we start with the Grignard reagent. So this is the Grignard reagent using to prepare alcohols from Grignard reagent. So this is also the second step, reduction process, and presence of lithium aluminum hydride or catalytic hydration, also catalytic hydrogenation, that means platinum hydrogenation and nickel hydrogenation reaction. This is also very important one. And this one, alkenes preparations, from alkenes hydroboration and mercuration and demercuration, this two reaction to this is also completed, and presence of acidic medium hydrolysis process to prepare the alcohol. So this is also very important one. And this one, and here the second this is also very important, alkyl halides to reaction with aqueous KOH. So this is a nucleophilic substitution reaction. This nucleophilic substitution reactions to conduct this process to prepare the alcohols, nucleophilic substitution reactions also. This is also very important one. Preparation of alcohols from esters also. This is also very important one. In esters involving in hydrolysis process to produce the alcohols from here. So this is also very important one. This one, ethers, is also in presence of dilute H2SO4. Dilute H2SO4 involving in hydrolysis process to produce the alcohols. Amines, nitration. Amines involving in a reaction with nitrous acid to produce the alcohols is the product. Val-Mary deamination. This reaction also, what are the moles of amine groups are present in the compound. So this is also very important reaction understanding. So this is also done here. Alkanes preparation reaction with the carbon monoxide plus H2 to prepare the alcohols. This is also completed. This one a very important one, the most important one. from glucose or carbohydrates. Carbohydrates. These carbohydrates under enzymatic reaction, enzymatic condition, were used as a yeast as an enzyme to produce the alcohols from here. So this is also one of the important preparation of alcohols from glucose. These are the mind map of preparation of alcohols from different starting materials, from alkenes, alkyl halides, and this carbonyl compounds, esters, ethers, amines, and this one last one carbohydrates. This is very useful in industrial process. We are preparing alcohol beverages in large quantity, and especially it is carbohydrate synthesis. Okay, now we are studying about the physical properties of the alcohols. So what is happening in physical properties of the alcohols are the less number of carbons soluble in water. If the carbon chain increases, what is happening? The solubility is decreases. So because of this reason, if the carbon chain are increases, that means the R hydrocarbon chain is increases, the solubility decreases. We can observe here from methanol and ethanol soluble in water, very well soluble in water, and propanol also. If the carbon chain are increases, then what is happening at 20 degrees temperature? What is the uh, amount of compound soluble? Because of this carbon chain is a non-polar chain, the water is a polar. So that's why if you increase the carbon chain, so what is happening? So that is the increasing of the carbon chain. So that means the carbon chain increases. So the compound polarity nature is decreases. At the same time, non-polarity nature increases. So that's why it does not soluble in water. So we are observing so many hydrocarbons like fuels, petroleum, chemicals, and kerosene. These are not soluble in water because of it is a non-polar compounds basically. So this is also here the carbon chain increases. What is happening? Um, the carbon chain increases, the polarity decreases, and the non-polarity increases. So finally, the compound is insoluble in water. So here we can observe here the methanol we have only one carbon, and ethanol two carbons, and propanol three carbons, and butanol four carbons. So the carbon chain increases, the polarity decreases. So what is happening? So in 100 grams of water, the only 8.14 grams of butanol is soluble. Then fentanyl. So here how many carbons are present in fentanyl? 5 carbons. So that's why mm, the carbon chain um, the carbon chain increases. That's why the pentanol dissolve in less soluble in water. The 2.64 grams in 100 grams of water only. And hexanol, it is very difficult, 0.59 grams. Because of the hexanol has 6 carbons, and heptanol 7 carbons. 0.09 grams are soluble in 100 grams of water at 20 degrees temperature. This is about the solubility. So what are the solubility factor? So generally the alcohols easily soluble, less number of carbons of alcohols easily soluble because of this formation of hydrogen bond between the water molecule and the alcohol. So let's see what is happening. So this is the hydrogen bond between the OH group and the water molecule. So this is the um, weak bond between the electrostatic attraction between the polar and groups. So O minus. So we know about the charge on the oxygen, negative charge, and the hydrogen plus charge. So this is between the two oxygen and hydrogen, weak attraction between this oxygen and hydrogen. And if you see here, the carbon chain increases. What is happening? The totally um, solubility decreases. So this is happening because of this polar non-polar chain is increases. So the polarity decreases. So this hydrogen bond between the weak electrostatic attraction between the two hydrogen and oxygen, highly electronate atom between the hydrogen. That is the hydrogen bonding. So oxygen here electron efficiency and the hydrogen electron deficiency. So this electron deficiency hydrogen atom attracted with the electron efficiency oxygen. So the attraction between the two compounds, it is weak electrostatic attraction. So that's why the water molecule is the ethyl alcohol or methanol, the carbon chain less carbon chain of the compound easily soluble in water. Okay, let's see what is happening at the melting and boiling points of these compounds. Okay, when compared to same number of alkanes and alcohols, so the boiling points are very high. When compared to same number of alkanes, alcohols boiling points are very high because of internal hydrogen bonding between the molecules. That's why the alcohols are more boiling points when compared to the same number of alkanes, same number of carbons alkanes. For example, here we start with simple example. Methane, the number of carbons 1, and methanol, number of carbon also 1. The boiling point of methane minus 164 degrees. Here the methanol 65 degrees. 65 degrees. So ethane minus 89 and ethanol 79 degrees, and propane minus 42 and 1 propanol 97, and butane minus 0.5 and butanol 117 degrees, and pentane 36 degrees, and pentanol 1 pentanol 138, hexane 69, and the 1 hexanol 156. We know about the boiling point. The molar mass of the compound increases, the boiling point also increases. Example, the boiling point is directly proportional to the molar mass of the compound. Molar mass of the compound. So, for example, from top to bottom, the molar mass is increases from methane to hexane. That's why the boiling point is increases. If the same number of carbon present in the alkenes and alcohols, what is happening? The alkanes have the less melting point, boiling point, because of there is no internal hydrogen bonding. So that's why there is less boiling point when compared to alcohols. So here also we can observe from methanol to ethanol and propanol, butanol, pentanol, hexanol, the number of carbons are increases, the molar mass also increases. That's why the boiling point increases from methanol 65, ethanol 79, and this one 97, 117, and 138, and 50, 156. Okay, that is the reason it show high boiling point when compared to alkenes. Alkanes. Okay. So, if the branching of the carbon chain increases, it reduces the surface area and contact with other molecules. So that's why the boiling points are decreases. For example, here we take a simple example of butanol. The one butanol boiling point is 117 degrees, and this is the isobutanol boiling point 18 degrees. This is the um, 2-butanol boiling point 99.5 degrees, and this is the tertiary butanol 82.5 degrees. Because of this carbon chain branches are increases, what is happening? The boiling point are decreases. What is the reason behind this? The branching of the carbon chain reduce the surface area. It's occupied the less surface area, it contact less contact to the other molecules, so that's why the boiling points are decreases. So this is happening. So with the same molar masses, but here these are all the constitutional isomers of the butanol. The general molecular formula of this C4 H10O, but different type of constitutional isomers of the C4H10 uh, O compound. And what is happening here? So the branching or increases, so the boiling points are decreases. This is happening. So this is also one of the important one. If the molar masses are very high, the boiling points are also very high, and the molecule between the bonding attraction between the hydrogen bonding attractions, that's why the molecules also very high boiling points. Okay, ఓకే, ఇది మన క్లాసు ఈరోజు. ఇంకా మళ్ళీ మనం రేపు డిస్కషన్ చేద్దాం. ఓకే, డౌట్స్ ఉంటే మీరు వాట్సాప్లో చేయండి. ఓకే, థ్యాంక్ యూ నాన్న.